Let's draw the Lewis structure for carbon tetrafluoride, determine the VSEPR geometry, and finally determine if it's a polar or non-polar molecule. Let's start by counting up the number of valence electrons to draw the Lewis structure. Carbon is in group 14. That last digit will tell you the number of valence electrons. Fluorine is in group 17. It's a halogen. Brings in 7 valence electrons. There are 4 of them. Gives us a total of 32 valence electrons. Carbon is less electronegative, so we'll put carbon in the center, put the 4 fluorines around it. Let's create a bonding pair between each of the terminal and the central atom. Each of those bonding pairs is 2 electrons that are shared, so let's reduce our total number of valence electrons by 8. So we're down to 24 valence electrons. Next step is to give the terminal atoms an octet. Each of the fluorines already has 2 in this bonding pair, so we'd like to give each of them 6 more to achieve the octet, and that 6 times 4 uses up the remaining 24 valence electrons. Carbon has also achieved the octet, 2, 4, 6, 8, so this is all looking good. Formal charges are all zeros all around. So this is your Lewis structure for carbon tetrafluoride. Now let's take a look at the VSEPR geometry. The central atom here is carbon. It has 1, 2, 3, 4 regions of electron density, or 4 effective pairs. When you have 4 regions of electron density that want maximum separation to minimize the repulsion, that geometry is going to be tetrahedral with 109.5 bond angles. So let's draw that using the line dash wedge. Put carbon there, put fluorine on the plane of the screen. This one is 109.5. And this fluorine is coming out at you, out of the screen, and this one is going behind the screen. Let's give them their valence electrons. Okay, is this a polar or non-polar molecule? If we take a look at the difference in electronegativity, the bond between the carbon and fluorine is polar. Fluorine is more electronegative, but because this molecule is symmetrical, these dipoles all cancel out, and so the molecule is nonpolar. So you can have a molecule with polar bonds, but if they all cancel out, then the molecule can be nonpolar.